Mecanum wheels are used on industrial machines such as forklifts because they allow you to strafe sideways, keeping your front end pointed towards the target, which allows you to line yourself up with more precision than a standard tank drive. With Omni wheels, you want to set each pair at opposite corners so that your front two wheels are either pointing towards or away from each other, and the opposite for the back wheels. Let's call these two wheels the A wheels and these two wheels the B wheels. When you turn the A wheels forward and the B wheels in reverse, you strafe to the right. When you turn the A wheels in reverse and the B wheels forward, you strafe to the left. You can still drive forward and backward like a normal tank drive, along with turning in place. But disadvantages? Not a lot. From what I could find, the main disadvantages are that they have less traction because they're giving up surface area for the rollers. Mecanum wheels also typically weigh more than traditional or Omni wheels due to the increased width. Mecanum wheels are pretty cool and fun, they just require a couple of minor trade-offs.
Hello, Dan here from howtomechatronics.com. In this video we will learn how to build an Arduino-based robot platform which is capable of moving in any direction. This unique mobility of the robot is achieved by using a special type of wheels called Mecanum wheels. I actually designed and 3D printed these wheels because they can be a bit expensive to buy. They work quite well, and I must say that driving this robot platform is so fun. We can wirelessly control the robot using the NRF24L01 radio transceiver modules, or in my case I am using my DIY RC transmitter, which I made in one of my previous videos. I also made it possible to be controlled using a smartphone via Bluetooth communication. I made a custom Android application through which we can control the Mecanum Wheels robot to move in any direction. Also, using the slider in the app, we can control the speed of movement. The brain of this robot platform is an Arduino Mega board, which controls each wheel individually. Each wheel is attached on an NEMA 17 stepper motor, and knowing the fact that stepper motors can be precisely controlled, I added one more cool feature in the app through which we can control the robot to move automatically. Using the save button we can save each position or step, and then the robot can automatically run and repeat these steps. With the same button we can pause the automatic operation as well as reset and delete all steps so we can store new ones. Make out of 8mm thick MDF boards. The 4 stepper motors are attached to this base platform and the Mecanum wheels are attached to the motor's shafts. A Mecanum wheel is a wheel with rollers attached to its circumference. These rollers are positioned diagonally, or by rotating the wheels in certain patterns, we utilize these diagonal forces and thus the robot can move in any direction. We should also note here that we need two types of Mecanum wheels, often referred to as left-handed and right-handed Mecanum wheels. The difference between them is the orientation of the rollers, and they must be installed in the robot in specific locations. The rotation axis of each wheel's top roller should point to the center of the robot. Here's a quick demonstration of how the robot moves depending on the wheel's rotation direction. There are screws for securing them. The most important thing here is to have the openings for the motors precisely made, so that all of the wheels have even contact with the surface later on. Of course, you could also 3D print this base platform. Instead, I spray painted the base and its cover with white color. My own ones. The wheels are made out of two parts, outer and inner side, which are secured together with some M4 bolts and nuts. They have 10 rollers each and a shaft coupler specifically designed to fit a NEMA 17-stepper motor. I 3D printed all of the parts for the Mecanum wheels using my Creality CR10 3D printer. There is also a link to this 3D printer in the video description in case you want to check it out. Just because I find 3D printing time lapses is So once I got the 3D printed parts ready, I moved on with making the shafts for the rollers. For that purpose, I used 3mm thick steel wire. The length of the shafts needs to be around 40mm. The length of the bolts needs to be 45mm. For installing the rollers, first we need to slightly insert the shaft through the holes of the inner side. Then we can insert a small M3 washer, insert the roller and push the shaft all the way into the slot of the outer side of the wheel. I used the single washer because I didn't have enough space to insert a second washer on the other side. I repeated this process for all 10 rollers. It's actually easy and kind of fun assembling these wheels. What's important here though is that the rollers need to be able to move freely. And next we need to attach the wheels to the motor's shafts. The shaft cover to the base, I attached threaded rods on the two corners of the base. I made holes on the same position on the cover, and so I was able to easily insert and secure the cover to the base. On the back side of the base I made 20mm hole for attaching a power switch later on, as well as 5mm hole for attaching an LED. Okay, so now we can move on with the electronics. Here's the complete circuit diagram of this project. So we will control the 4 NEMA 17-stepper motors.
Let's see print. Alright, now let's assemble in the part. Arduino IDE.